Okay, we're doing more word problems. So first thing is to analyze it. Just read it the first time and then read it again to model it. A rectangle is 7 centimeters longer than it is wide. So I have a rectangle. One side is 70 centimeters longer than the width. The diagonal of the rectangle is 4 centimeters longer than the longest side. Find the dimensions of the longest side to the nearest centimeters. So what we're going to do is just draw out a rectangle. We know we have one, and we know that we don't know any side. So one side is, let W represent the width. A rectangle is 7 centimeters longer than it is wide. So it's 7 centimeters longer. The diagonal of the rectangle is 4 centimeters longer than the longest side. The longest side is that. So that's the longest side's length, and it's 4 centimeters longer. Find the dimensions of the longest side. So, what is that longest side? We have to find W. Then W plus 7 will give us the longest side. But what's the relationship between these two? How can I find W? Is there a relationship between these sides? that's where we got that answer from. Where do we get this 4 from? Well, that's 8 over 2. And it's separate. The 2 is basically the fraction of both of these. It divides both. We separated that. We kept it here. And we have our two answers. You can substitute these values in a calculator because it says to the nearest centimeter. You can just solve it like that. You don't actually have to do this next step. Where did we get that from? We broke up 352 into 16 times 22. Do I expect you to know that? Not necessarily. I just did it because if you can do it, it's always better. So the answer is 13.38, and the other value is negative. It's that or 4 minus that. And we end up getting a negative value, and we don't want a negative value. We need a positive value. So, therefore, the longest side is 7 more than that, which is about 20 centimeters. Example 2. A ball is shot into the air. Its height h, we know this, the ball's going to travel like that, right? The ball h in meters after t seconds is modeled by h equals 4.9 t squared plus 30t plus 1.6. How long will the ball take to reach 35 meters? So when h is equal to 35, how long will it take? So we put in our equation, and we substitute h equals 35. It becomes minus 35. We move it to the other side of the equal sign. 1.6 minus 3.35 is 33.4. Now we use our formula. Okay, so minus b, and this becomes a question of using your calculator well. 30 squared for a is 4.9, c minus, remember always take the negative sign as well, times 2a, 4.9. And we just put it in our calculator. 2 times 4.9 is 9.8. Um, 30 squared is 900. 4 times 4.9 times negative 33.4. Don't forget this plus. This becomes a positive value. We end up getting 354. And you can just substitute all these values into 900 plus 654 is that value. I'd pop that into a calculator right now and figure out what that was, which was 39.43. So we have two answers. Separate the plus and minus. We have two answers now. Or we substitute it with we do the calculation with a positive, we do the calculation with a negative. So t equals 0.96. Or, therefore, the ball will take approximately 1 second to reach 35 meters. Question 2. This is all about modeling. A public rectangular, so we have a rectangle. Pool is 50 meters by 30 meters. Public schools must be surrounded by a cement walkway of uniform width and in the same width all around, like we've been doing, whose area is at least as large as the area of the pool. The area of the pool is equal. What is the minimum width of the walkway to the nearest meter? So don't let minimum fool you. It just means, so we're not looking for the minimum. What we're doing is finding the value at which it is equal to the size of the pool, and then it can be any size larger than that. The minimum area is where the pool and the walkway are the same. The area of the pool, 15 by 30, and the area of the walkway are the same. What's the area of the walkway? Well, length is what's the area of the walkway? The area of the walkway is the full length, 2x's and 15, plus 2x's and 30, that, minus the area of the pool. That's the area of the walkway, right? We took the full area. We have to take away 30 by 15. That's what we did there. And that should be equal to the area of the pool. So let's solve 30 by 15 first. Outside terms, oil. 2 times 15 is 30. 2 times 2, 2x times 2x is 4x squared. We have to join these, that becomes 90x. By the way, what's the area of the pool? 30 by 15, which is 450. By the way, we have this minus and this positive, so we can't cross them out, despite what I just did. Can't cross them out. Uh-oh, I think I made an error here. This 90 came from there. This 4x squared. Oh, here we go. Never mind, I didn't make an error. 450 minus 450 is 0. Take away 450, bring it to that side, right? Because of the equal sign. That's where we got the minus 450 from. Okay, can we divide by 4? Maybe, we can definitely divide. We can divide by 4, but we can just throw it in the quadratic formula as well. And we have minus b. That's where we get the minus 90. B squared, 90 squared, minus 4a and c minus 450. Let's clear our markings. This becomes positive. What's 4 times 4? 16 times 450. Put that into the calculator, we get that. 2 times 4 is 8. Now pump that into a calculator. Square root of 15300, 123.7. And what do we end up getting? 2 possible answers. Right? This plus becomes, it's all the same, except now we have 2 values, plus or minus. And we pump that into a calculator. It's either 4.2 meters or 26 negative. Can't be that, because it's negative. Therefore, the minimum width of the walkway is 4 meters. Why? The nearest meter. So we can have it 4 meters at 4.2 meters. The area of the pool, which was 450, will equal the area of the walkway. So here are the homework questions. I'll have them up posted.